Everything is made of atoms, but how are these tiny things able to generate enough energy to power up entire cities? And how are we able to control this energy from blowing up our nuclear plants? In this video, we'll go over what nuclear fission is, what nuclear fusion is, and how we harness nuclear energy as electricity. Let's go over the method nuclear plants use first, nuclear fission, which is splitting heavier elements into lighter ones. Each atom has a core called the nucleus at its center, containing protons and neutrons, bounded by a force called the strong force. This is where uranium-235 comes in, which is a metal that can easily be split apart. To start nuclear fission, a neutron is fired into the uranium, which then split into lighter elements, such as krypton-92 and barium-141, along with 3 neutrons and high amounts of heat energy from breaking a strong force. Then, the neutrons go on to smash into more uranium atoms to create a chain reaction of neutrons and energy. In order to prevent the chain reaction from turning into a nuclear bomb, nuclear plants have control rods that constantly absorb neutrons out of the reactions, making nuclear energy quite a controlled process. Lastly, the uranium that didn't undergo fission and the leftover atoms are disposed of as nuclear waste, as they are very radioactive. They are first cooled in a pool and then encased in concrete and lead deep underground. And of course, this means that nuclear fission is non-renewable, but it is a clean energy since it doesn't release carbon in the process. Despite that, it's a ridiculously powerful source of energy, as 1 kilogram of uranium can generate 24 million kilowatts per hour of heat, which is around 2 million times more than 1 kilogram of oil or coal. On the other hand, we can also combine lighter atoms together into heavier ones through nuclear fusion. The fuel used for fusion is deuterium and tritium, hydrogen atoms with 1 and 2 extra neutrons. When those two isotopes combine, a helium atom is produced, along with a neutron and a tremendous amount of heat energy. Energy is produced since the new helium atom has less mass than the 2 starting hydrogen isotopes, so the excess weight is converted into energy as described by Einstein's famous equation. This reaction generates 4 times more energy than fission reactions, and around 4 million times more energy than burning coal. It is also both renewable and clean, making it the ideal energy source. However, the main downside to fusion reactions is that they need temperatures of around 10 million degrees, which is only possible in stars such as our Sun. But we're getting pretty close to figuring out fusion reactors. So now, how do we get electricity out of the heat energy? We talked more about how electricity is generated in this video. But in short, in order to generate an electrical current, we need to spin a magnet inside a metal coil. As the heat generated by nuclear reactors heats up water around the fission reactor, a huge amount of steam is generated, which is the white smoke coming out of nuclear plants. Then, the steam turns the turbine blade, which spins magnets to produce enough electricity to supply 10% of the world's energy consumption. Fortunately, the steam is harmless and recycled back into the atmosphere as just water vapor. And there we have it. Fission is used to split atoms apart to release the energy that holds them together, while fusion is used to combine atoms to release energy as the product has a lower mass. Either way, the heat generated is used to convert water into steam, turning turbines to generate electricity without releasing greenhouse gases. Despite the popularity of using other sources of clean energy, nuclear energy is able to provide us more energy than we will ever imagine. I hope y'all have learned something interesting today. Thank you for your time, and stay hydrated.